So Reticulum is really powerful, but it's still really underrated for some reason. And that kind of surprised me, but I think I realized what it is. Or one of the reasons is that there's just not enough easy to digest information about how it works yet. And this video is my simple, humble little attempt to contribute towards fixing that. Now, Reticulum is often brought up in the context of things like Meshtastic and MeshCore, which is appropriate. You can definitely talk over LoRa via Reticulum, but so much more than that. It's so much more. And I want this to be a series of building block videos going over just how it works. And it's not meant to be technical. You don't have to be a developer to understand this. It's also not going to be a how-to guide to like set up a board and get chatting right away. There's quite a few out there at this point. That part I think is quite well covered, but it's more about just like understanding how can this technology, this system, this software allow for these kinds of autonomous networks and all these kind of powerful features that it has. So today, this video that you're seeing is going to be about what I consider, I think, the first building block, which is announces. Now, normally when you probably see content or just think about or talk about mesh networks, it's very common to have this kind of diagram, right? You see they're all interconnected. Even the Reticulum logo is like that too. And for good reason. I mean, it represents the fact that these are different pockets. They can communicate with each other and they can also be completely sovereign. But I'm going to start this off a little bit differently. I'm going to flip from the perspective of a single node first. I'm going to bring it into the real world too. So you, as the viewer, are going to go on this journey with me as someone who's been tasked to manage a mailroom, or our little version of a mailroom, at least, the Reticulum mailroom. And what you see here represents basically the 5 doors where mail may come in or out. And let me just move this real fast here. So mail may come in or out, so you can pop it in the outgoing from where we sit, or you'll get some coming in. Pretty straightforward. Now, question is, what's the protocol, right? What are the rules? What's the training? How would you do this? And the way that I want to give a baseline for the encryption part, you'll have to use a little imagination with me, please. But you're going to get a wax seal. We're going to pretend that these wax seals are completely unforgeable. So this seal of yours, that is definitely yours. If anyone were to see any mail pass through that has your wax seal on it, they might not know much else, but they can definitely say, okay, whoever has that wax seal sent this postage or sent this mail, whatever it might be. We'll talk about probably just postcards here today. Just keep it simple. But the point is, the wax seal is like a confirmation that this person is the right person that has this wax seal, because it's unforgeable. If you just bear with me on that, then the rest of this will get even more practical. So with that wax seal, I want you to think about if mail were to come through, and this would be an example of one. Basically just, hey, I'm announcing, and a wax seal with it. And at first it's kind of like, well, what can I do with that? Like, how am I going to route mail with that? But there's a really important characteristic, is that the fact that it came through that door, in this case, the purple door, is useful information. And if, again, those wax seals are unforgeable, so whoever owns that seal, that red seal with like flowers, I think it was, thank you, Google Images, for a few stock photos. Whoever has that definitely sent that through. Like, it came through, and that's definitely from whoever owns that seal. That's what we know. But it's easy to think like, okay, well, still, like, what can I do with that? Well, if we start keeping a list real quick here of which seals come from which doors when you see an announce, we'll do it with a simple little table, kind of a little image to color lookup. So you can just look at this and say, okay, this red flowery seal goes to that purple door. And then another one comes through, and let's say it's through the green door, and it's this seal. So again, you can add that to your list. Okay, so that makes sense, right? Now, what's the point of doing that? Well, let's say if someone were to give us something like this now, where they just say this needs to go to the owner of that red seal. And the contents of what else is in there in that mail is technically visible to you, but it's gibberish, right? I mean, this is where the encryption would come in, right? But to keep the analogy a little bit more real and physical, just assume it's gibberish, and whoever's getting it must have some way to do something with this info. It doesn't matter to you. You don't care. Point is, you just got to know where it goes. Well, in this case, we just saw, this was recently too, so it's probably still in your working memory, but certainly it's on our little table that we've created, that red flowery seal needs to go through the purple door. So if you were to receive this, you could easily just pass it over to the purple door. You don't have to know anything more than that, right? So far, I think it's pretty straightforward, pretty simple. Those of you who do understand Reticulum deeper, I'm going to leave out a lot of specifics, obviously. If you're a developer and going, well, wait a minute, what about this? And you're thinking about the systems, go look at the source code, read the manual, that kind of thing. This is meant to keep it conceptual, to understand just how the network works in general. So we've passed this along to purple door with the destination of that red flowery seal. Okay. So I did bury the lead a little bit, and I will expand a little bit more. Just a couple of things, not everything that actually happens with announces for real in Reticulum, but two simple but key things here. One is that you'll see I've added a little random ID. That's just an ID that's come through. And then how many hops it's gone so far. How many doors has it passed through before it got here? That kind of thing. So once you receive something like that, the way it would really work, and the way it works in Reticulum, the way that you actually end up building the network isn't just like we received an announce quietly and did nothing with it. You could do that if you were just listening as a node, by the way, but like as a peer, but typically we're thinking about like transport nodes and how this works. So for those who are in Reticulum, just understand, we're assuming everyone here is a transport node. If you don't know what that means, don't worry. I'm done talking about that. Now we have this little bit of extra information, an ID kind of just meaning like, hey, like this announcement. So if you saw another copy of it, you'd know, oh, I already saw that one, and that's the point. And then a hops just becomes useful extra information that helps just optimize the system a little bit. Now, when you get it, what you'd really do with it is actually not take a copy of that and pump that out each other door. So that's a key piece, right? I didn't do that in the first example just to kind of think about the idea of receiving those seals, but in reality, as soon as you get one, you'd also fire it out across there. So you've added it to your table, or updated your table in some cases, and then you sent it out the door to every other, whoever else is in this position, every other node, every other mailbox. And then we can look here again and see how I've kind of added this random ID to here just to point out, again, that's how you'd know if you see another one come through, you can go, oh, I've already seen that one. Not the full picture. Okay, of course, if you look at the code, there's a little bit more to it, but conceptually, that's the important part here. Now, I want to flip to this again. I teased it at the beginning, but everything I just showed you so far, all of this stuff here, that's effectively what drives the entire system to be able to route. Sounds like kind of crazy. I mean, that's it. Now, because of that, I want to now flip back up to this top-down view and point out that every node in Reticulum only has that mailbox view that I showed you. That's all they need to have, and it still works. I'll show you how. But this top-down view will pretend like we can magically see the entire network, which you really can't in practice. That's kind of the point, right? You have your own sovereign networks, and some will connect, some won't. Let's pretend like we could just see everything here in this system. So from the top down, I'm going to now zoom into this upper left one. So this one over here, I'm going to just zoom into this. And when we zoom into that, what we end up mapping this to is each of those lines in that typical kind of graph that you'd see, pretend like that's the door. And I use different colors here just to point out this is like a different scenario now, but the concept's the same. These are all doors that you'd send the information out, or you'd have the mail, come in. And in this case, this will be the wax seal of this node, this mailroom, we'll call it. And let's now think about how this starts to flow through the full system. So, okay. Let's say this node wants to just announce who they are. We don't have to even worry yet about forwarding other people's from this node. Just, hey, we're here. So we send that all out on every door that we have available. And in this case, I'm going to try to cut off just to keep it focused here on this part of the graph. Here's the 3 immediate other mail rooms that yours would connect to. And you can see now they've received it in on that door. In some cases, you've got mail rooms like this one where that's the only door they have. That's pretty simple, right? These ones is a fun example here, though. So it's received on this door in both cases. so far so good, but let's walk through what would kind of happen next in practice. So I'm going to jump down to this bottom one here, and it would have received that in, and as we talked about, it would pop that back out. And as you'll note, I just make a point here, this is where you'd add a hop to it. So this one had 1 hop coming in. Sorry, it's a little bit small, but 1 hop coming in, 2 hops going out. But the point was they got it and dumped it out the other possible doors it could go. And of course, then this node here would then be recording, okay, I know that this purple tree looking seal comes out from this door. So now it knows that and it has that recorded. So I'm not going to keep showing those tables, but you know that's happening under the hood. If we then take a moment actually and now go over to the other node, this one over here that received it. As this gets sent, remember it also received one from the original, the source node that has that wax seal. So it already has it. I'm kind of using gray here to show that arrow, meaning like it's a little bit more previous in time. So this one's about to be sent over to it, right? And as it does that, if we zoom in a little bit about what's going on there, you can kind of see, okay, it got this one, it already recorded it. I'm not showing the IDs here, forgive me, but these would be the same ID, they're just copies. So it'd be the same random ID. And so you'd know it's a duplicate. Not only is it a duplicate, but well, this one's got 2 hops. So 1 more than that on average probably means a little bit farther away. There's more risk of breakage, etc. But also you probably received it later. So that's also a thing you could consider. I'm not going to go into all of the decisions that go into that kind of thing. Again, you can see the code for that if that's what you're into. But conceptually, if you're just making up your own rules, you could figure out some reasonable things to think about, right? Okay. So when this comes in, this can just get dropped. You already have it. You already know, and you're going to send it through that door because you know that's where they came from. This one's not as good of a way to get it there, so you're going to just assume it's that door. So I'm eliminating that. It's been dropped. If we now think about what happens next, though, right? Or rather, I should back up, excuse me. When the first announce came in from the original source, this node would have also fired it off out of the other doors that it has. So what makes it interesting is to think about, well, okay, so this one down here, if we go back to where we started with this stuff, right? This node down here at the bottom is going to get another copy of it too. They kind of would almost, cross paths on the way there, as this one sends to over here, this one sends to over here. But because of the fact that they can both understand, hey, the other one I got from this other node had 2 hops on it, probably came in later, and we already knew where to go, so we just drop it. So, and what you're left with now is, and I'm kind of doing this sort of top-down look where I'm going to line up where this seal is with the door it should go out. From that node's individual point of view, it knows how to do that from the rules we just established. Doesn't have any magical knowledge about anything else, but that's all it needs for this to start working. So this one still knows this is the right path for that purple wax seal, and this one knows this is the right way to go. If we now look over at what would have happened over here on this part of the graph, and I've kind of put to the side there the other nodes just to focus on these two. But the same thing would have happened. I'm going to jump ahead the steps now, right? Same thing would happen. It would send it out over that door. It would have put the mail in that door, so to speak, and then it would have been received here, and this would know go out this way. If we, of course, just keep expanding on, well, what would happen next, we can look at that, right? So we just received it here, but now we're going to fire off the only other door that we have, which goes over here. As we fire that off, it's going to trigger the same thing. This one receives it and knows to go here. And by saying, hey, shove that mail out the other 2 doors, it does so. That's all it has to know what to do. Continue that a little bit further. And what ends up, what I've done here is that as it receives, or as these other 2 nodes were to receive it, not necessarily at the same time, just whenever they got their mail from that node, they would also fire off to each other, just like in that first group, how that happened. And I've already kind of pre-grayed them out to just symbol that they would ultimately get dropped. Now, here's the beautiful part where it all comes together. Not that. This. Here's what the network looks like now. Which the rules we followed were ridiculously simple, and yet it actually ends up working really, really well. And we didn't have to flood more than we had to. We have very good, efficient paths to get there. So if this node down here wants to get something to the purple seal, it knows all it has to do is put it out this door. In this case, that was the only door that it had. But then this node, same thing. Hey, I want to get something to the purple seal. Which way is it supposed to go? Well, out this door, which would land it here. Out this door, this node would send it, which lands it here. It'd go this way and then up to the purple node. So it can trace back the way that it came automatically without any individual node ever knowing anything more than just what to do for the next hop. Like, where do I send this thing? That's all I have to know. I'm letting that sit for a second because that's what I think is one of the really powerful things that you'll find with Reticulum as you're digging deeper, is that really, really good, powerful systems come out of it, but the individual rules are sensible and quite simple, which to me is a sign of a good system, right? Any good system is a simple system that's stacked with lots of simple systems. And that's what, hey, quick cut. Sorry about the jump scare there. Me from the future, realizing I had ended that video without even pointing out one of the coolest things about this. So far, I've been pointing out how amazing it is we can just route that way, right? We can just create an entire network by just that simple system. But if we go back to thinking about our mailbox analogy for a second, each one of those doors we could send information out on doesn't have to be the same kind of transport. It doesn't have to be the same kind of way you'd get the mail there. So, analogy first, let's say going out one door ends up taking it via purely trucks that would carry it there. One might go take some planes. One is potentially local, and so it's just handed off to the post office worker who would then walk it around the local neighborhoods. But the point is, it still works the same whether it came in from the plane and out the door on foot, or came back in on foot and gets loaded up on a truck, right? The concept, it completely works with that. So now to bring it into the practical part, punchline here, every one of those doors is a different interface in Reticulum, like LoRa radio, like your local Wi-Fi, like a TCP/IP connection, like any other kind of interface you can give it, Bluetooth. The point is, if you can move data in and out of it, it can be a Reticulum interface. And that's the part that gets really powerful, because one node that can hear on LoRa can still then push the information out to their local Wi-Fi, locally on Bluetooth, maybe also on LoRa, maybe not, it would at least just be kind of a repeater in that scenario, but also onto the open internet and vice versa. And that's what makes it incredibly powerful, and why you probably hear people talking about things like that, about how they can bridge LoRa to Wi-Fi Halo to an internet connection and so on, right? And that's how it does it, because that system of routing it based on announces like that doesn't care about how it got there. It doesn't have to, and the system still works. So thank you for taking this roughly 20 minutes to learn about this with me. And if you're watching this right now as I've released this, this is the only one. But if you're watching from the future, there probably will be more for you to watch and take the next steps in the series. But regardless, thank you for taking the time to watch this. I hope it was helpful. Let me know if there's anything that's still confusing about this topic, specifically in the comments. That would be the best place for that. But also, if a concept has come up that's been bugging you that you are trying to understand and you just want to seed the idea for future videos, then by all means leave a comment about that too. I'd love that. And worst case, if it's a topic that I don't know well enough yet, I can at least reach out to the community to help get informed and then help deliver the information this way. So thank you again for your time, and I hope you have a great day.